A team of researchers in China have discovered a stunning binary system in which a stellar object known as a pulsar orbited inside the outer layers of its companion star, which it accomplished after stripping its host's innards and dispersing them into space. The findings are an incredibly rare example of a spider star that preys on its companion, so named because of the female arachnids that devour males after mating, and tantalizingly, the grisly scene is some of the best evidence yet of a stage of stellar evolution called the common envelope phase, which has never been directly observed by astronomers. Pulsars are rapidly spinning neutron stars, the incredibly dense stellar cores that are left over in the aftermath of a supernova. Everything about neutron stars exhausts superlatives, their gravity most of all. They are so tightly packed, containing more mass than our sun inside a form just a dozen miles in radius, that all their atoms and their constituent protons and electrons have been crushed into neutrons, with just a teaspoon of this improbable matter weighing trillions of pounds. Their powerful magnetic fields, billions of times stronger than Earth's, unleash beams of radio waves into space along their poles, further beggaring belief. Some neutron stars become pulsars, which spin up to hundreds of times per second after siphoning material from a stellar companion, if it has one. Their sweeping beams of radiation, like cosmic lighthouses, look like a repeating signal to observers. The newly discovered pulsar, PSR J1928+1815, intrigued the astronomers because its radio pulses suggested that it was extremely close to its host, completing an orbit every 3.6 hours. They also noticed that for 1/6 of that orbit, the pulsar would vanish from view, indicating that the host was eclipsing it. That's a large part of the orbit. That's strange. Only a larger companion can do this. Observations revealed that the host star was between 1 to 1.6 times the mass of our Sun, while the pulsar was more likely 1.4 stellar masses. Determining the make of the host star, however, took some additional sleuthing. Its tight orbit, and the fact that it was only detectable in radio wavelengths, ruled out its being a Sun-like star. And since it was large enough to eclipse the pulsar, it had to be something larger than a stellar remnant like another neutron star. That pointed to something altogether more spectacular, a helium star, created after the pulsar, when it was still an ordinary neutron star, tore off its host's layers and created a huge common envelope, a cloud of hydrogen gas that swallows both the stars. In this case, the poor star under attack managed to cling on to its evacuated innards for just 1,000 years, a blink in a stellar lifespan, before the whole mighty envelope fell apart. Fleeting as it was, its impact is lasting. The friction exerted by the gases gradually nudged both